Hello, everyone. We're going to start 5.8, which is three-dimensional problems. I ask you not to look at your handout to start out with because I want to go through the method of drawing a picture yourself without just looking at the picture already drawn. So the picture you see here on this title slide it's a word problem that's really common. We're not going to do it because of the online learning. This one example is hard, but I'm just going to show you. So this is supposed to be Juliet in the tower. And you've got Romeo, and R is Romeo and P is Paris. So there's a word problem in your homework about let me just point to it here. There's a word problem about Juliet is standing on a tower, at the top of a tower. Romeo is looking at her with an angle of 20 degrees looking up. Paris is looking up at an angle of 18 degrees. And so these two are, this triangle I'm outlining here is supposed to be flat along the ground. And then these two triangles are supposed to be going up. So that's why it's called three-dimensional, because we have not just one triangle going in using a plane, a two-dimensional plane. We're in 3 dimensions right now. So this is a word problem that normally I would assign later, but I'm not going to assign this one. You might see it in your textbook, but this one's quite complicated actually, because you're not given quite as much information as you would be given normally. So just for the purposes of e-learning, I'm going to not do this one with you. So this is where I want you to just focus on the video here and not look at your handout, because I want to go step by step with how to draw this. We've got Manny standing at a point B, some distance away from the base of the cliff. So when you're doing your own questions, you need to visualize that. You need to visualize a cliff and then someone standing below it on the ground, on the shore, or whatever, far, some distance away. That would be Manny, okay? He uses a clinometer, and that's just a device that you can use that measures angles of elevation depression. So he uses a clinometer and determines the angle of elevation to the top of a cliff directly above him. So he's looking up from his spot way on the ground. He's looking up to the top of the cliff. And here's a clinometer. You can make one yourself at home. That's just a kind of homemade one, but definitely in any kind of engineering programs you might be taking, you would use a real clinometer. Hopefully in your mind you pictured something like this image here of this triangle. Here is Manny, right, at point B, and he's some distance away. I don't know this length here. That's his distance away from the bottom of the cliff. He's looking up to the top of the cliff, and he looks up with an angle of elevation of 38 degrees. And here's the next piece of the puzzle. We've got Joe. Joe's got to come into this picture here. He's standing at point D. So we're going to have to put a point D in here, 68.5 meters away from Manny. So try to figure out where that would be. So that could be anywhere. Here's Manny here at point B, 68.5 meters away. We could put that anywhere. We don't have a direction. We don't know if it's closer to the cliff or it's further out. We don't know. Joe estimates the angle between the base of the cliff himself and Manny to be 42. Manny estimates the angle between the base of the cliff himself to be 63, so we'll put that information in a second. Get a mental image of what this is. So we're first going to figure out where do we want to put Manny. Manny's at point D, so we can just stick Manny over here somewhere. We don't really know where he's supposed to be. We're going to put a point D there, and then we're going to put in all the other information that's in the question. So here we go. Here's point D added on there with the other information from the question. And you can look at your sheet now because your sheet already had this drawn for you. That's why I didn't want you to look ahead, because then you'd already see what it was supposed to look like and you maybe wouldn't be trying to visualize it. So the question says, what is the height of the cliff to the nearest tenth of a meter? So that's this, right? This is what we're looking for, the height of the cliff. H, that's how tall the cliff is from the bottom to the top. We're trying to find out the height of the cliff to the nearest tenth of a meter. So that's our problem. So we want to make sure we've got everything in our triangle. There's one more thing we could figure out ourselves, and that's this angle right in here, this bottom angle, see? So this is this plane, this triangle, imagine it being flat along the ground. This one is going up. This is a different dimension. That's why we're calling this 3D problems. So this angle right in here at angle C, this angle is going to be 180 degrees, right? This whole triangle right here, of course, all angles have a sum of 180 degrees. So you're going to take 180 degrees, you're going to subtract 42, subtract 63, and that's going to give you the measure of this angle right here. So we've got 75 degrees there. That bottom triangle is not a right triangle. Sometimes students will assume instead of 75, it's 90 because it almost kind of looks like it or it's drawn like it, but it can't be. If you have angles of 42 and 63, that third angle has to be a 75. You'll know it's a right angle if it's given to you in the question, or anytime you have a question that's from the ground up a pole or something like that, a wall in the ground, those are always going to be 90 degrees, but this one is 75 degrees. So now we have to figure out, the question is asking us, remember, for the height of this triangle. We've filled in everything that we can. If I just look at this top triangle here, and I'm trying to get the height, because it's a right angle, that's great. I could use sine, cos, or tan. So I could say, okay, well, I want to use sine, because sine is opposite over hypotenuse, but I don't know the hypotenuse, and I don't know the opposite. To use sine, cos, or tan, you have to know two pieces of information. To use SOHCAHTOA. So to use SOHCAHTOA, sine, cos, or tan with a right angle triangle, we have to know two things. Two things. So we need a side and an angle, or we need two sides. And in this triangle over here, all in this top triangle, the vertical triangle, all we have is one piece of information. We have this 38 degrees. We don't know anything else about it. So we're stuck. We can't go any further with this triangle. We're going to have to go down to this triangle because they share a side in common. Anytime you have two triangles, and you usually do in 3D questions, anytime you have two triangles, they usually share a side together or they share an angle together. If you can figure out the length of that common side, then you'll be able to use it in both triangles because they both share the same length here. So we go back down to this triangle. We have an opposite angle and side measurement here. That's the sine law. Remember that? Because we know an angle and we know its opposite side, its matching side, we can use the sine law. So we can use the sine law with these two and with the 42 and the common side here, and that'll give us this side. Then once we know the length of this side, we can move up onto this triangle here and go back to where we were. So the best way to use the sine law is to put the unknown in the numerator. And since we're looking for a side length, the side length we're looking for is side BC. We're going to put that in the numerator. Side BC over, or you could use a lowercase d if you wanted to, over sine of D. So we're looking for, side BC is what we're looking for. That's our unknown. And we're going to make that equal to a ratio where we know the angle and the side. So we have to put the side in the numerator. So that's going to be 68.5. We know that side. The other thing that we know is 75 degrees. So sine of 75. So we put put all this stuff in our that instead of a D there, I could have gone ahead and put a 42. Let me rewrite that. So BC over sine 42 equals 68.5 over sine of 75. So our unknown's in the numerator. That's good. With our unknown in the numerator, I want to leave this here. All I'm really going to do is multiply both sides. I'm going to cross multiply this up. I'm going to multiply basically both sides by sine of 42. That'll get rid of it here, and that'll bring it over to the other side. So we're going to have BC equals, and you can press pause here and go ahead and do the calculations yourself. So press pause, work it all out, come back and look at the answer, see if you got the same thing that I'm going to put. So I'm going to put a dot here for approximately. BC is approximately equal to 47.45. And that's meters. We don't really need that right now, but that's what that is. So I now know this side is 47.45. There's our common side. Really important to get a common side if you can. I should have put that up here. Find a common side. And then you can transfer between triangles. So we found the common side. It's 44.75. Now I'm going to go back up and look at this triangle. This is the original question, find the height, right? So now I can do that because remember I needed two things. So in this top vertical triangle, I've got one thing, I've got an angle, I've got another thing, I've got this side. So I've got two pieces of information. I can use SOHCAHTOA now because it's a right angle triangle. So I can use SOHCAHTOA to figure out what is the, so I want you to think about that before I give you the answer. Are you going to use sine? Do you have the opposite and the hypotenuse? Are you going to use cos? Do you have the adjacent and the hypotenuse? Or are you going to use tan, opposite and adjacent? So figure out what you know in this triangle and what you need in this triangle. Figure out if it's sine, cos, or tan. And hopefully you figured out it would be, well, let's see. We've got a right angle triangle. We're definitely going to use the 38. So opposite the 38 is the h. That's the side I need to find. So I definitely need to use a ratio that has the opposite in it. So that's going to be either this one, sine has opposite, tan has opposite in it. I'm also using this side right here. And that side is, so across from the right angle is the hypotenuse, right? So what's left over is the adjacent. So since we have an adjacent, we're going to use this one. I'm not going to use sine because then I have two unknowns. I don't know the opposite and I don't know the hypotenuse. So I wouldn't use sine, I'm going to use tan. Tan, the ratio is tan theta equals opposite over adjacent. So we're going to fill in what we know. We know that theta is 38 degrees. The opposite side. The opposite side is, we don't know that, that's h. The adjacent side is, that's our answer that we just got over there, 47.45. So here we're going to multiply these two together. We're going to multiply this number 47.45 up. So multiply those two numbers together. And then you should have h isolated. You get h equals 37.1 meters. And when we have a word problem, we always need a sentence after. So you'd write therefore the height. The height of the cliff is about 37.1 meters. This is very similar to one of the questions you're going to do in your homework. I think it's number 11. So when you get to number 11, come back and take a look at this one here. I think 11. Ooh, that doesn't look like an 11. Okay, number 11 is pretty similar to this question here. So that's all we're going to do. I know there's more on your handout, but we're not going to do that Romeo and Juliet question there. You can look at it if you want to. You can see that the height is the common side there that we need to find, but there's some more information missing that makes it harder. So there is homework listed on the back, on the bottom of your handout. I'm not going to assign all of that. So go back to the D2L page here and take a look at what I assigned. There's a text error there too, and that's shown on your handout. Good luck. Post questions if you have any, and just do the practice.